Hi everyone, this is Professor Oaks, and in this video I am going to demonstrate how to find the volume of the solid of uh, revolution here, generated by revolving the curve y equals the square root of x on the interval from 1 to 4 about the x-axis. All right, so revolve about the x-axis and using the shell method. All right, so find the volume using the shell method. All right, so of course I would tell you that the shell method is not the easiest method to use here. It's actually the disk method, and if you find the volume of this using the disk method, you would just have, all right, so the volume using the disk method is integral from 1 to 4 of pi times the square root of x squared dx, which worked out to 15 pi over 2. All right, so this is what you would get using the disk method. All right, so let's use the shell method here just to verify that you would get the same result. So I can see here that I have two portions of the graph here when I look at this using the shell method. I have the rectangle part right here. All right, and then this is bounded by x equals 1 and x equals 4. So this is x equals 1 and x equals 4. And then on the top by y equals 1 and y equals 0. And then I have this part right here, right like this, that is bounded by the, what do I have here? I have the x equals 4. And then remember when I solved for the function, actually when well, actually not, this is probably not the right way to say it, but when I solved for this here in terms of y, I got y squared is equal to x. So this is x is equal to y squared. All right, so if I actually draw some rectangles in here, right, and again these are just representative rectangles, or if I draw some rectangles in here, right, which I can do that. Right, now these rectangles all have the width of a delta y, delta y, delta y, delta y. Remember, like this is just a representative rectangle, and so we would be getting infinitely many of these, and that's how it ends up being the integral. All right, so just remember that. Now for the shell method, remember that the formula is, all right, so let me go ahead and write this down here. All right, for when we have a horizontal axis of revolution, like the x-axis is here, we have volume is 2 pi integral from c to d of y times g of y dy. Now, remember, the y is the distance from the rectangle to the axis. So in both of these cases, I can say fairly easily that this would be a y. All right. So whether and by the way, remember that even though this is this region right here is on top of that rectangle, the distance of any one of those individual rectangles, so this is still the x-axis right here, and that's still the x-axis right there, the distance is still from here, from any one of the rectangles down to the axis is still y, and from any one of the rectangles down to the axis is still y. All right, so remember that it's the g of y that is actually going to be different here. All right, so here's the volume using the shell method. All right, so from y equals the 0 to 1. All right, so and by the way, I can actually draw other stuff in here if you would like. That's y equals 2, and this is y equals 1. All right. So from y equals 0 to y equals 1, I have 2 pi, and then the distance from the rectangle to the axis, which is y, and then I have g of y and g of y. Remember, these are functions in terms of y, so these are functions of the form x equals something. All right, so in this case, I go from x equals 4 to x equals 1, so I have 4 minus 1. Now this might seem a little bit strange, but we are going from x equals 4 to x equals 1, and not say x equals 4 to x equals 0. So that's why this is a little bit more difficult, of course, than using the disk method. All right. So now that will be dy then plus the integral. So from when y goes from 1 to 2, we have 2 pi times y, the distance from the top of any rectangle to the x-axis, all right, y, and then times. Now, what is the length of this rectangle? So this one, the length of this rectangle is 4 minus 1, so that's 3. The length of this one will be the where is it? The 4, right, minus the y squared. So we're going from x equals 4 over to x equals y squared, or from x equals y squared really over to x equals 4. But you get the point that you need to subtract those to figure out the length of that rectangle, and then times dy. All right, so now of course, now you see that this is a completely more complicated setup than when I used the disk method. All right, so this tells you why sometimes you really do want to use the disk method, and sometimes why you want to use the shell method. So now I have integral from 0 to 1, and 4 minus 1 is 3. So I have 2 pi times y times 3, so that will be 6 pi y, all right, dy, and then plus integral from 1 to 2. Now, this is actually, let's see, so 2 pi y times 4, that will be 8 pi y minus 2 pi y times y squared, so 2 pi y cubed dy. Now I integrate, so let's integrate. So I have the 6 pi times 1/2 y squared, evaluate it from 0 to 1, plus, all right, 8 pi times 1/2 y squared, and then minus 2 pi times 1/4 y to the 4th, and that is evaluated from 1 to 2. All right, so what do we have here? Well, this is actually, let's just simplify that. A 6 times 1/2 is 3. So 3 pi y squared, evaluate it from 0 to 1, plus 8 pi times 1/2 y squared. That's 4 pi y squared minus 2 pi times 1/4 y squared. That's a pi over, what is that? That's a pi over 2y to the 4th, evaluate it from 1 to 2. So what do we have now? We have 3 pi times 1 squared minus 0 squared, plus we have 4 pi times 2 squared, right, which is 4, minus pi over 2 times the 2 to the 4th, which is 16, then minus, all right, 4 pi times 1 squared minus pi over 2 times 1 to the 4th. So we're left with 3 pi, and then this will be 16 pi minus 8 pi, so that's actually, what do you have? That's actually 16 pi, all right, minus 8 pi, that's actually, what is it? Oh boy. Yeah, 8 pi, and then we have 4 pi minus pi over 2. So if I distribute that, that's actually minus 4 pi and then plus pi over 2. So then that will be, what is that? If I do that, 7 pi plus pi over 2, which then if I find a common denominator, oh boy, this is going to be 15 pi over 2, which is the same result now using the shell method to find the volume as I would have gotten using the much easier integral to find this volume using the disk method. All right, so anyway, I really hope that you enjoyed this video here about the shell method. Thank you and have a great day.